Welcome back, everybody. I hope you enjoyed that video clip. Again, it's one of my favorite ones. You can definitely understand George Banks' frustrations. When it comes to wanting to grill out hot dogs, you go to the store, you buy your hot dogs, you buy your hot dog buns, but they're never going to be the same amount in each package. One's going to be packaged with 8, the other's going to be in a package of 10, sometimes they're in a package of 12. It all depends on who's making it. But usually what's going to happen is you're going to run out of one of your ingredients before you run out of another ingredient. And that can get kind of frustrating sometimes, because then you're trying to figure out, what am I going to do with the rest of this leftover stuff? The same thing can occur in chemistry. In chemistry, you're going to have a lot of different containers of different compounds. And what's usually going to occur is when you perform an experiment, you're always going to run out of one compound first before you run out of any of the others. And with the others, you're going to end up having leftovers. So the reactant or reactants that you're working with that end up having leftover are going to be called your excess reactant. The reactant that you're working with and you run out of it is going to be called your limiting reactant. Once you use up all of your limiting reactant, the whole chemical reaction stops. You can't produce any more of a product when you're missing one of the main ingredients, right? Same thing with cooking. If you're trying to bake cookies and you run out of eggs, you can't make any more because you have to go to the store and buy more eggs. So basically you stop making cookies, right? So let's say I gave you 2 different vials, okay? And I said, I want you to figure out how much of a product you can create. Well, in order to do this, you have to know the mass of each of the reactants that you're working with. Once you figure out the mass of each of the reactants that you're working with, you're going to do mass-to-mass conversions using each one of those reactants. So you're going to do a mass-to-mass conversion going from one reactant to the product, and then you're going to do another mass-to-mass reaction going from the other reactant to the same product. Now, I mentioned the same product because sometimes you're going to be performing experiments and it's going to have multiple products being produced, kind of like the last ones we've been working with in the previous episodes. When that occurs and you're trying to figure out what your limiting reactant is and what your excess reactant is, you always have to do these mass-to-mass conversions going to the same product the whole time, okay? That's really, really important to keep in mind. Now, once you do these mass-to-mass conversions, an easy way to determine the mass of your product is you compare those theoretical yields. Whichever the theoretical yields is the smallest value, that is going to be the mass of your product. Because you remember, you cannot produce any more of a product once you run out of the limiting reactant. So the reactant that produces the smallest product is going to be your limiting reactant, which means the other reactant is going to be in excess. You're going to have leftovers of that. So this is going to make a lot more sense once we practice it up on the board, okay?